This Zoom session is being brought to you by the Fractal Hex Bullseye Water. All right, 6.8 and 6.9. 6.8 is about applying rational equations. It's word problems in short. As ever, the hardest part of a word problem in math is translating the words into mathematics or into algebra. And really in this section, as usual with the words problem sections, they hi there, Kitty. They are the math has already been done. We've already discussed the math. We just have to do the translation. And sometimes the book insists on solving it in such and such a way, when in fact there's often sometimes an easier way to do something. Okay, we're being interrupted by a cat. Well, apologies. I have to pay the cat tax. There you go. Out you go. Cat treats thrown out the door. They'll run after, and I'd shut it afterwards. Maybe you saw the cat's tail. The cat got a lion cut, has some sort of little poof of lion-like tuft at the end of his tail. Never mind. Okay, here we go. So for this one, I think it actually makes more sense to really reason it out verbally. But here we go. A homeowner can re-roof his house in 7 days. A roofer can do it in 4 days. How long would it take them if they work together and combined work rates add? Okay, first we have to talk about this quantity, rate, and time. Quantity equals rate times time. So rate equals quantity over time, time equals quantity over rate. Now the homeowner's rate is 1 roof in 7 days, and the roofer's rate is 1 roof in 4 days. So the combined rate, assuming that the combined work rates add, is 1/7 plus 1/4 of a roof per day. And the combined time is quantity over combined rate. So 1 roof by 1/7 plus 1/4. So 1 over 1/7 plus 1/4. Reciprocal, the sum of reciprocals. All right, so you do some cross multiplying, flip it upside down. 28 over 11 days, that's 2 6/11 days. All right. Now, here we go. Notice this expression, reciprocal of sum of reciprocals. And it works out to be product over sum. I call this reduction. We have various, this shows up in work time problems, but also speed time problems. And later I will show you we have an extra credit set about just that in the Canvas. All right, this is a similar one, a rate time problem. One pipe fills a pond in 3 weeks, another pipe can fill it in 5 weeks, and evaporation can empty the pond in 10 weeks. How long does it take for both pipes to fill an empty pond? So first a pipe has a rate of 1 pond in every 3 weeks. Second pipe has 1 pond in every 5 weeks. And the evaporation rate is negative because it's emptying the pond, -1 pond for every 10 weeks. So 1/3 pond per week, 1/5 pond per week, minus 1/10 pond per week. So if you combine these, 1/3 plus 1/5 minus 1/10 of a pond per week, and the combined time will be 1 over that, like we had over here. Time equals quantity over rate. And so you get reciprocal of 1/3 plus 1/5 minus 1/10 weeks, and you do the arithmetic. Bob, it's simple math or whatever arithmetic. I mean, 30 over 13 weeks are 2 4/13 of a week. Okay, similar thing here. One pipe can fill a pond in 10 seconds. Second pump can fill the pool in 15 seconds, and the third pipe can fill it in 20 seconds. How long does it take all pipes working together to fill the pond? Now again, same reasoning. These are times, so the rates are reciprocals. 1/10 of a pond pool per second for this. This pipe 2 has a rate of 1/15 of a pool per second. Pipe 3 has a rate of 1/20 of a pool per second. So assuming that they add together, which makes sense, then the total flow is 1/10 plus 1/15 plus 1/20 of a pond per second, which after a bit of arithmetic is 13/60 of a pond per second. And that's the rate. And then the time is quantity over rate. So 1 pool divided by 13/60 of a pool per second. Therefore, 60 13 seconds, or 4 8/13 of a second. Here's another combined rate thing. All these are basically reduced to reduction, we perceive. Man takes 3 hours to wash and wax the car. Him with his son takes 1 hour to wash and wax. How long would take the son working alone? The man's rate is 1/3 of a car per hour. Man and son's rate is 1/1 car per hour. So the son's rate is the difference between the two, 1/1 minus 1/3, or 2/3 of a car per hour. So his time is 1 car divided by that rate, 2/3 of a car per hour, 3.2 hours, or 1.5 hours. So, and all of these, the problems there are pretty much that. Like the book tries to make it a big algebra thing, but as you can see, if you just use common sense, find rate is quantity over time, add the rates, time is quantity over rate, and that gets you the answer.